All right, so first I just want to make sure I was clear what was going on in the special case problem key that you just looked at. So there were two answers, two angles. And that is because, and you don't need to write this down. Okay, so anything I put on this sheet, this is just making sure you understand what was going on in that key and what's going to be relevant to this conversation we're about to have. So there are, let's remember our special case range equation is that delta x is v naught squared sine 2 theta over g. And so if you think about what's going on, so what we found, and this should make sense, is that there's two angles you can fire something at to have it land in the same spot. So for example, imagine you kicked a soccer ball at a really shallow angle, so it didn't go very far. You should also be able to kick it really, really high up into the air. It would spend a long time in the air. It would go basically straight up and come basically straight back down. And there should be some other angle where you can get it to land in exactly the same spot. And the reason is because of this 2 theta that we have right here. So remember that on the unit circle, this is cosine, the y-axis is sine. And because theta can be anything from 0 to 90, 2 theta can be anything from 0 to 180. And so if, for example, your angle is, 10 degrees, 2 theta is going to be 20, right? And so the sine of 20 degrees is going to be whatever this y coordinate is here, but there's some other angle that has the exact same y coordinate, the same sine value, and you can see it's symmetrical. And so if this is 20, this is going to be 20 away from 180, or 160. And so if 2 times our angle was 160, then theta's got to be 80. And so there's always going to be two angles that can produce the same sine value when we do sine of 2 theta, because our range is anywhere from 0 to 180. And so any value except for something that's going to give us our maximum value, there's always going to be two angles that can give us any particular angle along here. So we'd like to see what exactly is going on, and this is a relationship that is pretty important. It's something that would be fair game conceptually for the AP test, where you might get a multiple choice question or something about this. So we're going to talk about it for the special case. So there's going to be patterns in special case projectiles.